Today we're going to finish up Unit 3, particularly our section on circular motion, by looking at circular friction. That is, we'd like to see how we can figure out whether or not a car can make it around the turn safely. Okay, so I want to remind you of some things we've already learned, and then we'll go on to some new applications of that stuff. So I want to start out by reminding you what we learned about force friction. So we saw that force friction went hand in hand with force normal. The greater the force pushing two surfaces together, the greater friction that was created between them. We saw we had a formula that looked like force friction equals the coefficient of friction times force normal. That coefficient of friction is the slope of our graph, and that coefficient of friction can be found on our yellow reference sheet. Okay, so again, a reminder, when you're doing force friction, start by finding the force of gravity. Set the force of gravity equal to force normal, and then plug into the formula for force friction. So we've used that before when friction was acting to stop an object from sliding. Now we're going to look at friction not as an agent to stop something, but an agent to change the direction that the object is moving. So when we have a car moving in a circle, our force friction is going to be pointing toward the center of the circle. It's not going to be used to make the car stop. It's going to be used to make the car change direction. Okay, so we still do the same process to find the value of friction. It just takes on a different role. It keeps the car from sliding out of the turn. So when we watch the car in the turn, friction is what allows it to successfully navigate the turn. And when the roadway is covered in ice, we may not have enough friction to successfully make it around the turn. All right? Even when the roadway is dry, if we try to go too fast, it's possible that we don't have enough friction and we continue sliding in a straight line. All right, so friction is key to determining, can we make it around the turn safely? Okay, so when you're doing your calculations, you're going to start with your force gravity equation. You're going to get your value for gravity, plug it in as force normal, get your friction. Your friction will then go in as your net force, allowing you to find your acceleration. Your acceleration will then go in your circular acceleration formula. You'll solve for the velocity, and then sometimes you'll plug that velocity in here to find one of the values for your circular speed formula. Okay, you won't always do that last step, but you should know how to do it just in case. Okay, so there's two things you're going to be able to do with force friction on turns. One is you want to be able to find the maximum speed you could go around the given turn. Okay, so here is our turn. Our turn has a radius of 120 meters. Our car has a mass of 800 kilograms, and the coefficient of friction is 0.75. So what you're going to do is start out with step one. Force gravity equals mass times 9.8. Get that value for force gravity, plug it in as force normal, using your coefficient of friction of 0.75. Once you get your force friction, you're going to plug that in to your Newton's second law equation to get your acceleration. Take your acceleration, put it in here, plug in the radius of your turn down here, and you're going to solve for the velocity. That velocity will be the maximum speed you could go around that turn. Once we have that velocity, maybe we want to know how much time it's going to take us to navigate the turn, so we can use this last equation. Note that we're not going around a full circle. We're only going around a quarter of a circle. So instead of using 6.28 as our delta angle, we're going to divide that by 4 before we plug it in. All right, but other than that, you shouldn't have any problem. These are all formulas we've used before. You're just stringing them together to find the maximum speed to go around the turn. Okay, the other thing you might want to do with friction is find the minimum radius that you can make a turn. So if you're on a road like Route 55, you want to make sure that you never have to slow down. So the designers of the road will make sure no turn is so sharp that you can't successfully navigate it at the speed limit for the road. So we're going to assume the speed limit for the road is about 70 miles an hour, approximately 35 meters per second. We're going to assume the coefficient of friction is kind of low. We want to design our roadway assuming that some tires are not going to be the best and that the road conditions won't always be optimal. Okay, and we want to find what is the sharpest turn that we can put in our roadway so that you never have to put up one of those little yellow signs to have people slow down. So your first step is the same as before. Second step, same as before. Okay, your third step, same as before. So again, gravity goes in for normal, friction goes in as your net force. Acceleration goes in here. This time you are solving for the radius because you already know the velocity that you want your car to be able to travel. All right, so you plug all those in, solve for radius. Hopefully you won't have any problem with that. Okay, it would also be nice if you could learn how to do a real turn. So what we're going to do is I'm going to ask you guys to find the maximum speed that you go around the turn, and the turn we're going to do is in the heart of Indianapolis. So if you go onto your Chromebooks and you go on to Google Maps, you start out here in Franklinville, zoom out so you get a sense of where you are in the country, go west until you find Indianapolis, zoom in on Indianapolis, and right at the heart of the city, we don't want to go to the Speedway, but we want to look for the War Museum, and then right near the War Museum, we will see right here, Monument Circle. Okay, it's a giant circle in the heart of Indianapolis. You could search for the Soldiers and Sailors Monument. You want to switch over to satellite view. And I just want to make sure you know how to measure. So go down to measure distance. And I'm not going to actually measure what you're supposed to measure. What you're supposed to measure is the diameter of the circle. So then you cut that in half and get the radius of your circle. All right, so I'd like you to try finding this circle, measuring the radius so you know how big the circle is. Then I'd like you to imagine a 1,000-kilogram car. You'll notice that it's not a normal roadway, but it's actually a brick surface. We're going to assume the coefficient of friction between your tires and those bricks is 0.59. And I'd like you to see if you can figure out the RPMs and the maximum speed. So go through the same process you did before, so it's nothing new. The only difference is your radius is not a number that I made up, but it's a number that you actually measured. All right, so good luck. Hopefully you understand how to do all these things. Make sure you complete whatever else is attached to your Google Classroom for the day.